Okay, so hello and welcome back. So in this video we will continue with what we were doing in the previous video, which was the properties, I think, of matrix multiplication, or if I'm not mistaken, yes, the properties of matrix multiplication. Now we have an exercise here that wants to show that the properties of matrix multiplication, as we discussed before, were the associative law. So to review, we said that, and I think we need a little bit more space here. I will write this here and then we will move to some other sheet. So we said that basically there was something called the associative law, which is basically if you have any three matrices A, B, C, then A times B times C is the same thing as A times B times C. That is called the associative law. Of course, whenever both of these, both sides are defined, it could be that at least one of the sides is not defined, and in that case you cannot do this. So this is the associative law. The distributive law, the distributive law is basically when you have any three matrices A, B, C, A times B plus C is the same thing as A times B plus A times C, and also A plus B times C is equal to A times C plus B times C. Plus B times C, whenever, of course, both sides of each of these equations is defined. And the third one was the existence of the existence of the multiplicative identity, which is basically for every square matrix A, A, there exists an identity matrix of the same order. There exists an identity matrix of the same order, such that I times A is equal to A times I is equal to A. And I is basically we will of course get to that. Now the question that we wanted to answer here was example number 18, and that is basically, suppose that we have a matrix, a square matrix A. This is example 18. Suppose that you have some matrix A as 1, 2, 3, 3, negative 2, 1, 4, 2, 1, and you want to show that basically A cube minus 23a minus 40i is equal to O, right? So you need to basically put these one by one together and then calculate each part, then put them together and then verify if that is equal to O. Now to calculate a cube, you know that a cube is the same thing as a times a squared. Now, of course, you know that that matrix multiplication is not necessarily commutative, meaning that if you write, for example, a times b, if a times b and if ab and ba are both defined, they're not necessarily the same. They will not necessarily have the same values, meaning that, for example, let's say that a is equal to 1, 2, 3, 4 and b is equal to, for example, 2, 3, 4, 6. Now a times b would be equal to basically 1, 2, 3, 4 times, for example, 2, 3, 4, 6. And if you do this calculation, you will get basically 1 times 2 is equal to 2, and basically 2 times 4 is equal to 8. Then you have 1 times 3 is equal to 3, 2 times 6 is equal to 12. Then you have basically 3 times 2 is equal to 6, and 4 times 4 is equal to 16. And then you have 3 times 3 is equal to 9, and 4 times 6 is equal to 24. And that is equal to basically 2 plus 8 is equal to 10, 3 plus 12 is equal to 15, and 6 plus 16 is equal to 22. And 9 plus 24 is equal to 33. So that is a times b. Now b times a in this case would be 2, 3, 4, 6 times 1, 2, 3, and 4, which is equal to basically 2 times 1 is equal to 2, plus 3 times 3 is equal to 9, and then you have 2 times 2 is equal to 4, 3 times 4 is equal to 12, and you have basically 4 times 1 is equal to 4, and 6 times 3 is equal to 18. And then you have 4 times 2 is equal to 8, and 6 times 4 is equal to 24. And when you add these together, you'll get 11, 16, and 18 plus 4 is equal to 22, and 24 plus 8 is equal to 32. So you can, and that is basically b times a. So you can see that they are, of course, not the same matrices. But for whatever reason, and I don't see the reason right now, for whatever reason, what I can see here is that when you want to calculate a cube, basically you can write it as a times a squared, or you can write it as a squared times a, and you will get the same matrices. And I don't understand how that happens, but that's probably, you can investigate that, which is of course something important. So now if I calculate, for example, if I start with a squared, I will have a squared is equal to a times a, and then since I'm dealing with A and A, it doesn't really matter whether I write 8 times A or 8 times A. That would be basically the same thing. So then I have basically 1, 2, 3, 3, negative 2, 1, 4, 2, 1. And here I have again 1, 2, 3, 3, negative 2, 1, and 4, 2, 1. And then if I do this multiplication, I will have basically this row, this column. So 1 times 6 times 12. 1 plus 6 plus 12, excuse me, 1 plus 6 plus 12. Then I have 1 times 2 is equal to 2, and 2 times negative 2 is equal to negative 4, and 3 times 2 is equal to 6. And then this column I have 1 times 3 is equal to 3, 2 times 2 is equal to 2, 3 times 1 is equal to 3. Then I will have this row and this column, so 3 plus negative 6 plus 4. And then I have to move to this column. 3 times 2 is equal to 6, and negative 2 times negative 2 is equal to 4, and 1 times 2 is equal to 2. And then moving to this column, I have 3 times 3 is equal to 9, and negative 2 times 1 is equal to negative 2, plus 1 times 1 is equal to 1. And then moving to the next column, the next row, this column, 4 times 1 is equal to 4, 2 times 3 is equal to 6, and 1 times 4 is equal to 4. 4 times 2 is equal to 8. 2 times 4 times 2 is equal to 8. 2 times negative 2 is equal to negative 4. 1 times 2 is equal to 2. 4 times 3 is equal to 12. 2 times 1 is equal to 2. 1 times 1 is equal to 1. That would be my matrix. And so that is 7 plus 12 is equal to 19, and 6 plus 2 is equal to 8 minus 4 is equal to 4. 6 plus 2 is equal to 8. 7 minus 6 is equal to 1. 8 plus 4 is equal to 12. And 10 minus 2 is equal to 8. 8 plus 6 is equal to 14. 10 minus 4 is equal to 6. And 14, 15. So this is A squared, 19, 4, 8, 112, 8, 112, 8, 14, 6, 15. Now, if A cube, if I take it as, which wouldn't make any difference really, as I have actually tested this. If I write A cube as A times A squared, if I write A cube as A times A squared, we have, so this is A, which is 1, 2, 3, 3, negative 2, 1, 4, 2, 1, and A squared is this matrix, which is 19, 19, 4, 8, 1, 12, 8, 14, 6, 15. If I do this calculation, what I will get is, basically, let me write this properly. Okay, so you have here and here, so you have 19 plus 2 plus 3 times 14 is equal to 3 times 14 is equal to, what is 3 times 10 is equal to 30, 3 times 4 is equal to 12, 42. And moving to this column, I have basically 1 times 4 is equal to 4, 2 times 4 is equal to 24, and 3 times 6 is equal to 18. Moving to this column, I have 8 plus 16 plus 45. 8 plus 16 plus 45. Then we have, okay, so now the next row of the new matrix, I need to take this row and this column. 3 times 19 is equal to 30, and 20 is 57. And negative 2 times 1 is equal to negative 2. And 1 times 14 is equal to 14. This column, 3 times 12 is 3 times 4 is equal to 12. And negative 2 times 12 is equal to negative 24. And 1 times 6 is equal to 6. Moving to this column, I have 3 times 8 is equal to 28. And negative 16 plus 15. Then this row and this column, 4 times 19 is equal to 40, 36, 76. And 2 times 1 is equal to 2. And 1 times 14 is equal to 14. Then moving to this column, I have 4 times 4 is equal to 16. 2 times 12 is equal to 24. And 1 times 6 is equal to 6. Moving to this column, I have 4 times is equal to 32. And 2 times 8 is equal to 16. And 1 times 15 is equal to 15. So then your matrix becomes 19 plus 42 plus 2. So 19 plus 2 is equal to 21. 21 plus 42 is equal to 63. Right? 24 plus 4 is equal to 28. 28 plus 18 is equal to 46. 8 plus 16 is equal to 24. 24 plus 45 is equal to 69. Now this is 55. 55 plus 14 is equal to 69. Negative 12 plus 6 is equal to negative 6. And then 15 plus 28 is equal to, let's say, 30 plus 40. 30 plus 4 plus 15 is equal to 45. 43. 43 minus 16 is equal to basically 9 plus 7 and 27. We have 27 there. And 16 plus 76, that's a 92. And basically 26, 24 plus 6 equal to 30. 30, 46. And basically 15 plus 16 is equal to 31. 31 plus 32 is equal to 63. So that is that. Now let me check my answer with the answer that we have in the book. We have 63, 46, 69. 69 negative 623. That's supposed to be 23. I was suspecting that I made a mistake here. You see, this is 28 plus 15, which is equal to 13. 8 plus 5 is equal to 13. And 1 here, so you have 43. 43 minus 16 is equal to 3 and 13. And what is that? That is 20. 6 plus 6, 7. That's supposed to be 27, unless I made a mistake over here. I think I made a mistake. So if you want to trace this back, you have to go to the second row, third column. 3 times second row, third column. 3 times 8 is equal to 24. 24, that is a mistake. Negative 16 and 15. And so then 24 plus 15 is equal to 39. 39 minus 16 is equal to 23, of course. Right. Now 16 plus 76 is equal to 92, 46, 63. So this matrix is correct, except for one mistake that I made here. Now if you have many matrices to multiply and so on and so forth, sometimes your mind is, well, sometimes your mind is tired, but still you have to keep doing your work. Sometimes it's so, although I would not recommend this for the whole the rest of your life, but sometimes you have to do this. And once you, in such cases, if you know how to do matrix multiplication, then of course you can use some, there are some for example calculators online that you can use. For example, you see, if you go to matrixcalc.org, matrixcalculator.org, if you go, for example, if you enter these two matrices here, matrix A and matrix B, and then you can calculate A times B, A plus B, and A minus B. And for example, if I enter my matrices here and hit A times B, instantly I will get some matrix here. And it gives you all of these wonderful options like insert in B, copy, show math ML, show as plain text, show as image, and so on and so forth. So for example, you can, I don't know what I would do, for example, with this, but for example, math ML would be something like this that you could enter into your website. Or for example, plain text would be the representation of the matrix in plain text, and I don't know what sort of machine would understand this code. There is also, for example, latex. That's also the kind of language that is used by some machines. So you have all of these different possibilities here. And also basically there is, for example, if you have a calculator like this, you can always, and you can download this calculator free of cost from the internet. And then you can, for example, say that I want to insert a matrix of order, for example, 3 rows and 3 columns. And then it will give me a calculator like this. I enter some matrix here. For example, 5, 6, 6, for example, 8, 9, or 9 here, and then I want to multiply it by some other matrix of the same order, for example 1, 2, for example 3 or 4, 3, 5, 6, 7, for example 8 and 9. If I hit enter here, it will give me the multiplication of those, of the product of those two matrices. So that you can do at least in order to check the result of your work, right? But as long as you are working based on some text, usually the right answer is in the text, and if you make any mistakes, of course you can catch yourself. For example, I made this mistake over here and I could simply see it. So now what I wanted to calculate was this expression over here, a cubed minus 23a minus 40i. So if I write a cubed minus 23a minus 40i, that would be basically, this is a cube. So I write this as 63, 46, 69, 69, negative 6, 23, 92, 46, 63, and that is a cube minus 23 times a. A was 1, 2, 3, 1, 2, 3, 3, negative 2, 1, 4, 2, 1, and negative 40i. I is basically the identity matrix, and the identity matrix is the kind of matrix of the same order 3 by 3, but then the diagonal, only the elements across the diagonal are 1, all the other elements are 0. So you have basically 1, 0, 0, 0, 1, 0, 0, 0, 1, right? That would be the identity matrix of order 3. And then you can multiply and calculate this thing over here, which is basically 63, 46, 69, 69, negative 6, 23, 92, 46, 63, and do this as, for example, negative 23 times this matrix would give me 23, 46, 3 times 23 is 69, 3 times 23 is 69, negative 2 times 23 is equal to 40, negative 46, 23, 23 times 4 is equal to 80, and 12 is equal to 92, 46, 23, minus 40 times this matrix would give me 40, 0, 0, 0, 40, 0, 0, 0, 40. Now, in order to do the subtraction, I need to add the opposite of these matrices, the algebraic opposite, the negative of these matrices, back to the rest of the lot. So I can write this as 63, 46, 69, 60. What is that? 60, 69, right? 69, negative 6, 23, 92, 46, 63, and I need this as plus, and the negative of this matrix, negative 23, 46, negative 46, negative 69, negative 69, 46, negative 23, negative 92, negative 46, negative 23. Plus again, and the negative of this matrix, which is negative 40, 0, 0, 0, negative 40, 0, 0, 0, negative 40. Now you can do the whole thing together, meaning that you can add 63 plus negative 23 plus negative 40, which is of course possible. So you can write this as, for example, 63 negative 23 negative 40, again 46 minus 46 plus 0, for example, 69 minus 69 plus 0, and then over here you can write 69 minus 69 plus 0, and then you have negative 6 plus 46 minus 40, and then you have 23 minus 23 plus 0, 92 minus 92 plus 0, 46 minus 46 plus 0, and then you have 63 minus 23 minus 40. And then you will have basically negative 23 negative 40 is negative 63 plus 63 is equal to 0. 46 minus 46 is equal to 0. 69 minus 69 is equal to 0. 69 minus 69 is 0. Negative 46 plus 46 0. 23 minus 23 is 0. 92 minus 92 is 0. 0, and negative 63 plus 63 is equal to 0, which is actually equal to the 0 matrix O. That is the 0 matrix. So pretty simple, except that for whatever reason here in this exercise, here it doesn't, when you write a cube is equal to, you can write it as a squared times a, and that is actually equal to a times a squared. You might want to investigate that. Okay, so we have question number 19, and that is: in a legislative assembly election, a political group hired a public relations firm to promote its candidate in 3 ways: telephone, house calls, and letters. So there are 3 ways that they are doing their promotions: telephone, house calls, and letters. Now the cost per contact for each option is given by A is equal to this matrix as 40, 150, and that is cost per contact, and that is for telephone, that is for house call, that is for letter. Given as this matrix. Now the number of contacts of each type made in two cities X and Y is given by the number of contacts of each type made in two cities X and Y is given by B is equal to basically 1,000, 500, 5,000, 3,000, 1,000, and 10,000. And that is for telephone, that is for house call, and that is for letter. And this is for city X, and this is for city Y. So what you want to do is that you want to find the total amount spent. Find the total amount spent by the group in the two cities X and Y. By the group in cities X and Y, right? So what you need to do is that basically this is the cost per contact of each option: telephone, house call, and letter, this matrix A, and this is the number of contacts made in each of those categories for two cities, right? For two cities X and Y. So if I multiply, for example, if I calculate BA, I would be multiplying, for example, 1,000 times 40 plus 500 times, for example, 100, and 5,000 times 50. That would give me a matrix of 2 by 1. And that would be basically the total amount spent by the group in cities X and Y. Okay? So I'm going to calculate basically BA, which is equal to basically 1,000, 500, 5,000, 3,000, 1,000, 10,000, and multiply that by basically 40, 100, 50, is equal to basically, so now this is a 2 by 3 matrix, this is a 3 by 1 matrix, so you'll get a 2 by 1 matrix, which means that you will get 1,000 times, for example, 40 is 40,000, plus, for example, 500 times 100 is 50,000. I think the cost is probably in rupees. That's 25. That's 25,000. And then you have basically this one, and then you have 3,000 times 4 is equal to 12, and 1 0 here, 0 0 0, plus, for example, 1,000 times 100 is equal to 100,000, 100,000 plus, for example, 10,000 times 50 is equal to 5 and 5 zeros. 5 and 5 zeros, so that's 500,000. So that gives me basically this matrix. And this matrix is the same thing as basically 40,000, 50,000 is 90,000. 90,000 plus 250,000 is let's say that it's 100,000, 340,000, 330,000, right? 330,000. And then you have 120,000, 100,000, 220,000, 720,000. Actually, we should for these are basically, this is the cost, and that would be the basically this would be for X and this would be for Y, and so that is the total amount spent by the group. Therefore the total amount spent by the group in the two cities is 340,000 paisa and is 340,000 paisa. These are in paisa, not in rupees, meaning that you have to divide by 1,000 to get them in rupees, because each 100 paisa is equal to 1 rupee basically. And 720,000 paisa, that is basically 3,400 rupees. 3,400 rupees and 7,200 rupees respectively. Right? So pretty simple. You just need to make sure that you write the matrices in the right order, otherwise you would get some answer, provided that, of course, the way that you write your matrices, multiplication is defined. But then, depending on how you write your matrices, the result will represent different quantities. So you need to write them in such a way that you get the quantity that you're looking for. Otherwise, it doesn't really matter how you write them, as long as you stick to the rules of matrix multiplication. However you write the matrices doesn't make any difference. Again, as long as you stick to the rules of matrix multiplication completely. We have many exercises here, 22 of them. They are going to take a century to solve, but we will solve them and we will move forward. So I'll see you in the next video, and thank you.